Now it's recording.
Thank you.
So, okay, now I lost my thought. Sorry? Yes. The problem is that there was 2 dates which were somehow in the for the final exam, and the final exam will be the 16th of December. In some places there is the note that it would be 20th of December, but this is not correct. It is 16th of December. There are 2 exercise groups, so I try to improve my skills in assembling this system in the lecture rooms. I studied it last Friday, but it was in a different lecture room and it operated in a different manner. So I have to learn how to choose this, which cameras, which screens are shown, and so on. So this was completely new system to me. There will be, so for example, I don't know exactly where the lectures are always because of this problem that Tudo, which tells me that where the lectures are, probably is not up to date. So for example, today it's L5. Do you know what is the, yes, on Wednesday, where it will be on Wednesday? Here as well. Yes, it's the same for me. No, exercises are somewhere else. They are held by Pauliina Uusitalo. The other group, okay, I have to check this one. So we agreed with Pauliina that the other group is a distant, so remote exercise. People who are not in Oulu. And the other one is on site. And now at this moment, I can't remember which was when this remote, but I can ask through Teams from Pauliina in a minute that when the remote lectures are, and when is the lectures are on site. She will respond soon. And at least on Wednesday morning, I will tell you exactly when. Is it Thursday or Friday? Thursday, okay. And Friday is the on-site exercise. Don't write it down because Pauliina makes the decision. Sorry? Okay. The remote exercise is Thursday morning from 8 to 10. And on Friday, it's on-site exercise. I think it is from, is it from 2 to 4? Yes, it starts already this week. Thursday, it starts on Thursday morning, is the remote exercise through Zoom. And we have to put up the link, but the link will be in the Moodle. Anyway, at least today it will appear in the Moodle workspace, the link to the exercise groups. The link should be in Moodle for the remote exam already in the Moodle. I didn't check up. It is the last link on because it's scheduled that, so there is every week something. And yes, it's already the link there. And on-site exercises are on Friday from 2 to 4. And it is in the lecture room DS 128. $128 DS. Then there will be, during the, besides the exercises, there will be these stack exercises. There will be only 4. So they are computer automated, and the system checks by itself if is your answer correct or not. And this is where you get some points. So for example, there will be 4, so you will get 4 points, and those are included in the final grade. Then the final exam, which is already this, told you that it is 16th of December. The time is always for our exams 4:15, and it will last 3 hours. And there will be 4 questions rated from 0 to 6 points. And so altogether you can from the exam 24 points, and altogether 28 points. And I guarantee that if you get 14 points, I guarantee that you will pass the course. But it can be lower. This, when I checked, when I marked your exams, it can be lower. That's, for example, it can be 13 or 12, depending in which mood I am. what else? Any questions at this point?
Can I ask through Zoom?
Yes.
Is this a remote exam or is it in the campus?
It will be both. It will be a remote exam and on campus. So you can choose if you want to be here on the lecture room, and those, of course, who are not in Finland, it has to be a remote exams, just like in numerical matrix analysis. Exactly the same procedure. I'm not sure how many of you are abroad. So slowly, very slowly, we will move our teaching back to the on-site teaching. So when this pandemic is finished, I will destroy Zoom, Teams, everything. I hate those things. So I hope that after the new year, we will be in more or less normal situation. So okay, maybe we will go directly to the topic. So the aim of this course is, of course, to teach you some important things about optimization. So first of all is to learn some algorithms and also some theory background of optimization, so that when you find a so-called optimal solution, then you need the criteria to identify that why this solution is an optimal solution. And then the algorithm provides some approximation, and then when to stop. When we are close enough the true solution. Of course, these numerical approximations are not, usually they don't find in the finite steps the true solution. Maybe you have already encountered this problem in Marco's course on numerical matrix analysis. I'm not exactly aware of what kind of things he taught you, but usually they are iterative techniques, and then these iterations usually don't find the solution of the linear system of equation exactly. So we have to make a decision when we stop. And it is exactly the same for optimization algorithms. They are also iterative algorithms, which utilizes some techniques from numerical matrix analysis or something else. And then, of course, we should understand, for example, that we have some kind of an algorithm for solving optimization problems. We have to know that, is this algorithm always applicable? Is there some limitations when we can't use it? But of course, this course is nowadays 28 hours lectures and only 14 or 16 hours exercises. We can't do too much. So, for example, 10 years ago, this course was 45 hours, so much more time to study the optimization problems. Now we don't have this luxury anymore. So what I expect from you, from your previous knowledge, is that you have understanding of calculus. So some understanding of multivariate calculus. So I expect that you know what is a gradient and what is a Hessian matrix. And then something about matrix analysis. So at least you understand that what is the inverse matrix, when a matrix has an inverse, and so on. Okay, there is a lot of there are questions that when is the exam time again? It's here. The exam is Thursday, 16th of December at 16 hours. So here are some examples of optimization. So optimization appears everywhere. So for example, in economic planning, such as allocation of resources. So for example, if you have some amount of extra money, you can invest them in various assets, shares, obligations, derivatives, and so bonds or whatever. And then when you make the investment decision, you have, of course, the constraint. So you have a budget. You don't have more money to put on these assets. And then what you want to optimize is, of course, for example, the income. So every share is paid dividend, and it is something like 20 cents per share or something like that. And then you have a fixed period of time. So for example, 2 or 10 years, and then you try to maximize your income or minimize your risk. This is an optimization problem. The other example is comes from shape optimization. So for example, you will produce a tool. Unfortunately, I have destroyed some pictures of, for example, the making a tool, for example, a wrench. So you have some material, you make this wrench so that it has the let's say the maximum strain is contained with the minimal amount of material, for example, steel. So what is the shape to get this to get the required properties from the tool? Or for example, you want to build up an airplane and the constraints are minimum volume, height, length, and so on. And you want to minimize the aerodynamical force on the plane. And of course, the problem in example 2, it is infinite dimensional, because it's a continuum number of shapes. But of course, after discretization, it becomes a finite dimensional problem. But it is a huge problem. And then there really appears the problem that how you compute the optimal solution, because the number of unknowns and the number of these different shapes is very, very large. The third one is an engineering problem as well, device sizing of electronic components, or for example, circuits. The variables are the device widths and lengths. Constraints are manufacturing limits, timing requirements, maximum area, and so on and so on. I remember from my work background, 20 years ago, more or less exactly 20 years ago, I was working for Nokia mobile phones. And then the big bosses came in and they said that it was the €2 coin. And they said that you have to make a phone of this size. Because at that time it was the competition that who makes the smallest phone. Nowadays it's the competition who has the largest phone, more or less, because we have the touch screen. Of course, inside here, the radio or the phone, it is already on the size of a €2 coin. Even I guess it is even less. But it was the time you have to optimize. So at that time, the phones, for example, the first 3G, third generation phone was it was a big apparatus. And then it was told us that you have to optimize, you have to minimize the size with the same operations as the big one. So those are the, let's say, more or less the real life examples. Of course, in this course, we don't go to this type of problems, because this is first course, so the problems are more or less simpler, because we are more interested on the two things: to identify the necessary and sufficient conditions when we have achieved the optimal solution. And the second one, the basic algorithms which are used for finding the optimal solution. Here are the general concepts of optimization. So we have always some functions which we want to minimize. And I will call it an objective function or cost function. And in my course, we are always minimizing. So I minimize always. I transform, even if the problem is of maximizing something, I transfer it to minimizing something by multiplying by -1 the cost function or the function which we are optimizing. So maximizing something is the same as minimizing minus something. So I present everything in that way, that we are minimizing. Then we may have some constraints. So constraints like inequalities. So we have some functions GIs, and we require that these functions, depending on this variable x, are not, they are below some limit. And usually I write this inequality constraints in a way that the function is less than 0. And then of course we may have equality constraints, but always the equality constraints can be transformed as inequality constraints. So if hk equals 0, it's the same as hk is less than 0 and minus hkx is less than 0. So this means that mainly I'll present all the theory and problems in the form that they are inequality constraints. And then I will just tell what will happen when we have equality constraints. So I will call a point x an admissible solution if it satisfies the constraints. So it's in the constraint set. The point is in the constraint set, then it is an admissible solution. And of course, optimal solution is the one which provides the smallest value for the cost function fx. And at this point, and then of course, we have problems where we don't have any constraints. And those are the unconstrained problems. Because there are some problems where there is no constraints at all. And for example, I will take now this. So the first example, I will put those. Okay, there is someone asking something in chat. No. These slides which are in this OneNote, which I write here in this on this draw board, I will put them also on the Moodle later on. So everything will be there as a PDF file. There is some system that I can even share it online directly, but I don't want to use too much technology here because I'm sure that I will mix up with something. So for example, we have this problem that we want to locate the target. So we have put